Let us try to solve the problem number 4 in the networking lab. In this particular exercise, we are supposed to implement a bus topology using the network simulator. Before we build the simulation, let's try to learn few things about the bus topology. So what is a bus topology as such? What do we mean by saying that we have a bus topology? So in the bus topology, what we have is we have a bus that is a common connector that connects multiple nodes. So all of them transfers or communicate using this common path. So every node is connected to the bus, and definitely we have connectors and terminator and so on and so forth, but that is physically we are not interested in looking at what are the things which are there. So let's logically look at how the communication works. Now suppose if you take a wire, let's say a coaxial wire, and then connect all the computers to this common wire and then start communicating, what will be the result? Will you be able to transfer the data from one side to the other side? The answer is obviously no. You will not be able to send even one bit across this particular common communication line. What is the problem? Why you cannot send the data even though you have connected all of them together? It is easy to view this thing that you have a common path here and you would connect all the nodes together and they will start communicating. So if you connect all of them to the common path over here, instead of communication, they will start misbehaving. What is the meaning of saying they will start misbehaving? Okay, so let's assume that you have two nodes, one on the one side, the other one on the other side. One thing you must understand here is when you start transmitting the data, it will not immediately reach to the other side. There will be some transmission delay. Maybe it is in millisecond or maybe in microsecond. There will be a delay. So as somebody starts talking at this end, there is no possibility that the other side who is there on the extreme side may not be able to listen to it. It will take some time for the data or the communication packets to reach to the other side. There will be some delay. So what is going to happen is two machines will start communicating at the same time. So this will also send, the other machine will also send. The result is at some point of time both the packet will collide with each other and both of them will lose their packets. So if you connect many machines to a common communication path and you expect that they are going to communicate, the answer is they will not be able to send anything, because what is going to happen is this machine will think that okay, there is a common path, why not we send something over here? So curiosity will be there. So this second machine will also think that okay, there is a common path, let me send some data, let's see what is going to happen. This will also start sending, okay, let me also try whether there is one path is there, it seems, so let me also send few packets. And the result is everybody will start sending everything at one time or maybe at other time, and there will be just a chaos there. You won't be able to do anything. So there must be a control, as to who is going to send and who is going to receive. It is like, you know very well, in the on your road, near the traffic junction, if there is no traffic signal at the junction, everybody will start crossing here and there, and the end result is nobody will be able to do anything, and there will be a traffic jam. So same thing is going to happen. So before a node sends the data, it must ensure that the channel is free. If somebody else is already transmitting, then it has to wait. So only when it realizes that the channel is free, then only it is supposed to send the packet. But you know very well, when the nodes are far away from each other, even though one node is sending the data, other may not be able to sense it. The reason is there will be a transmission delay. So after it sends, before the packet reaches to the other side, the other node at the extreme side may think, or maybe wrongly take it as the channel is free, and they may start sending the packet. And when both of them start sending packet, at somewhere within the network, the packets will collide, and there will be garbage content over here, and both of them has to wait for a random amount of time, and then they will retry. This story you have already studied, and this is called as carrier sense multiple access with collision detection. So CSMA CD. So this CSMA CD is very much required. Let's look at the one other problem which may not disturb the communication, but definitely it is going to reduce the efficiency, or it is going to waste the bandwidth. And what is that problem? See, let's assume that the node here, I'll just call this node as A and this node as B. Okay, two nodes, whatever the nodes may be, they want to communicate. So A will send the packet. Let's assume that there is no collision or nothing of this sort. So when A sends the packet, it's going to give the destination as B. It is going to say that this packet is supposed to be received by B, and it sends the packet. Now when this packet is sent, it is replicated, and every node is going to receive that packet. Whether they want it or not, they will receive one copy. So you know, we will copy paste, you are doing it during the submission of assignment. So same copy paste is done, and a replica of the same packet is given to all the nodes. If there are 100 nodes, 100 nodes will receive it. All of them will check the destination address. All of them will check here what is the destination address, and they will compare that destination address with their address. So this machine will check, okay, the destination address is B. Am I B? No, I am not B. So what it's going to do is it's going to discard this packet. Similarly, this node will receive this packet and check whether the destination address is same as its address. If not, it's going to drop that packet. Same thing is true. This node will also receive it, but its destination address is not the same, and it will discard it. And finally, B will receive the packet. And once the B receives the packet, it will check whether its address is same as the destination address in the packet, and then it's going to consume it. Now once the B has consumed it, in your connection oriented communication that you have seen, or in particular TCP, you have seen, B will send an acknowledgement. Acknowledgement is again a packet with the address saying that it is acknowledging that it has received a packet to the destination A, because this has to reach to the A node here. Now the problem again is, once this packet comes into the common bus over here, it is replicated, and everybody will receive that acknowledgement. Even though these nodes have nothing to do with the communication, they will receive acknowledgement from the B. And what they will going to do, they will just discard this, because they say that I have nothing to do with this communication. Simply you are giving an acknowledgement to me, I have not transmitted anything, but I am receiving it. They simply discard that. But A will receive it and then act accordingly. Okay. So what's the problem here? The problem is you are simply wasting your bandwidth. Only one communication is there, but you are simply generating too many packets and then sending it to all of them. So where do you generally see that particular thing? So this is how the communication works. So you send a packet, it is replicated to all of them. The unconcerned nodes will discard this packet. Now if you see the communication channel over here, we know that OSI model is there. You are all familiar with this OSI model. Now there are devices which are available, physical devices that you see is available at this last three of the, let's say it might not last, the first three layers. A physical layer we have the some networking gadgets which are coming over here. At data link we have some networking gadgets which are coming over here. At network layer also we have something. At the physical layer we have the hub. What's the functioning of the hub is whenever a hub receives any packet in one of the node, it will replicate that thing along all of them. So once it receives it, it will replicate it to all of them. So when a hub receives something from the node A, it will replicate it to this one, it will replicate it to this one, it will replicate the same packet to this one. So everywhere, every location over here, you are going to get the replica. So if you want to know where this particular idea is being used up, it is generally used in the hub. Hub does this work. You send a packet to the hub. If it has 5 connection, it will give the same packet regardless of what it is, whether it is an acknowledgement, whether it is a data packet, whether it's a control packet. It simply replicates it across all the nodes over here. Now because I have just talked about this network OSI reference model, so let's look at what are the technologies that are being used there. So when we talk about the OSI layer over here, we will not interact with the network layer. It's not a network communication that is happening over here, because you don't have any network there. It is a single LAN, that is called as a local area network, that is getting connected. So the technology that being used here is either Ethernet or the token ring or ATM and frame relay. So all of them are working in these two layers of the OSI model, and that is the data link layer and physical layer. Generally, the Ethernet is used in the LAN. So your local area network, we use Ethernet. So that is the one that is being used. And if you look at this model in a slightly expanded way, you are definitely you will agree that data link layer is subdivided into two layers, and one is the logical link layer, that is LLC, and the other one is the MAC layer. And physically is electronic communication. We generally don't deal with it. However, you must understand two things over here. Is you have the Ethernet standard in the physical layer is 80203. So this is the number that is being used up. So 80203 is your Ethernet standard, and then you have the fast Ethernet, gigabit Ethernet, and so on and so forth. So when the Ethernet started, it was 10 Mbps was the idea. Now you have a GB, hundreds of GB can be transferred across the Ethernet. So across this 802 standard. So they have a different standard over here, and these are all a specification, physical specification, whether you are using coaxial cable, whether you are using optical cable, and so on and so forth. But what is important over here is the subdivision of data link layer, and that is the logical link LL and the MAC layer. Now, at least you are familiar, MAC is responsible for one important thing, and that is the physical address. You are familiar with the IP address, which is available in the network layer. So whenever you say IP address, IP address, IP address, IP address is there at the network layer. Physical address is there in the MAC layer. So MAC layer or MAC address, we say MAC address is responsible for the physical address, and remember, you cannot change the MAC address of a machine. It is embedded inside the network adapter card which is coming over there. You can't change it. However, you can always change your network address. It is directly possible. So when you connect to the Airtel, whether you connect to Jio or when you connect BSNL or any other network for that matter, you are given an IP address, and that IP address is not permanent. The same IP address can be reused and given to somebody else when you are not using your connection. So this is not permanent. You can always change your IP address. Okay. However, you cannot think of changing the MAC address. Definitely, there are some hacks which are available, which you can say, and you can come and say that no, sir, it is possible to change the MAC address. But generally talking, MAC address is considered as a permanent address, and who is responsible is this MAC layer. What else does this MAC layer does? MAC layer is responsible for CSMA CD. So I told you, yes, carrier sense multiple access with the collision detection. This is done by this MAC layer. And what does if this is done by this layer? Definitely, it is responsible for the flow of control. That is, you have two machines over here. Let's say. If the image is coming, let's say one good image, if it's coming, okay, you have two nodes over here which want to communicate. If this is a Google server, it can send at extremely fast speed, and if this is your machine at home, it may not be able to receive at that speed. So there must be a flow, you must control the flow. Okay. If you go to this petrol station, and not the petrol station which is there on your local nukkad mein jo hai wo nahi, if you go to the highway, and there are petrol stations are there, generally they don't entertain you. If you take your two-wheeler, scooter or bike, they don't entertain you. They are waiting for the big trucks to come. Okay, the trucks don't put petrols, they use diesel. So if you look at their speed, if you just watch how they are doing, those diesel, they are at a time they are filling it to 200 liter, 350 liters, like that, full tank they are doing. So there, the speed with which the petrol or diesel is pumped out, that this in the petrol station you have this one gadget is there with the pipe like this. This pipe is very thick, if you notice that, because it is going to pump at a very high speed. If you go to your petrol station there, the pipe, even though it looks same, but inside it is very thin. So at a time maximum you may put 5 liters, or if the car person comes, they may go for 20 liters, not more than that. But whereas these people, the truck people, 350 liters. See, remember, just imagine if it is it takes 1 minute to put 1 liter, 350 means that he has to wait for the entire day. So the speed with which the diesel is pumped out is very fast, and the truck is able to handle it because it has a very high capacity. Just imagine you take your Activa or maybe your scooty or your bike there, which has 20 liters capacity, the Activa, and 6 liters capacity. Within a second, it will be overflow. Okay, if that big pipe is being used. So in the same way, when somebody is sending the packet, the other side must be able to receive it. If the other side is not able to receive it, then you must other side must say that don't send it at that rate. Okay, this is called as flow of control. It is where do we handle this situation? In the OSI layer, you have this transport layer. Transport layer is responsible for that. But there is other problem that also appears with the communication, and that is when you send it, will it, I am not to see, the first thing what I said is one machine is sending at a very fast rate and the other machine is not able to take up at that speed very fast, highly many. It's like you go to the petrol station, you go to the diesel and try to put it, diesel onto your Activa. Within a second, within seconds the tank will be full and it will overflow. Okay, so at that speed your scooter may not be able to take up that much of fuel within seconds. So you have to reduce. This reduction is done at the logical layer, but there is other thing that is there. Now just I will give you one other example. Now again, this is example of this trucks. Now if you go to highway again, in the highway you have these trucks are there which are very with maybe 10s or 12s tires with them, very very big trucks are there. Okay, they can easily go in your highways because highway is very broad and there is hardly any narrow cuts are there, so it is straight. Most of the highway now today you see all highways are very straight. Okay, but just imagine if that truck comes to your local gully or nukkad, if that truck enters your nukkad with such a big truck, it will not be able to go in this small road over here because it may not be able to turn. Okay, so the reason is your gully or you say nukkad or oni, whatever you say, they are narrow. Okay, so the one who is sending, if this truck, if you look at this truck, the size is very large and it may not be able to incorporate. That problem is there are two problems. One is you are sending it at a very fast rate, other side is not able to receive. The next one is the size is very large that the network itself cannot take. Now who is not able to take? Look at the two differences you must see. You took your Activa and you try to fill the tank of the Activa with the diesel, not the diesel, that big pipe. Okay, then it will overflow. This is, the receiver cannot handle it. This other problem is very different one. You have a very large packet, okay, and this packet cannot be transferred across the communication link. This here the road has a problem, the path has a problem, path cannot take such a large capacity. Okay, so this is also flow control. In that case what you are supposed to do, so you get a very large big truck there with the 8 tires or 10 tires and that tire can't come. So what they will do is, sometime you will see that they will get a pickup, small pickup, they will get it, they will take some part of it, they will put it in this pickup, Mahindra or any other, and this will go in any nukkad. You know, this Mahindra will go at any place. So that 4x trucks, the pickups are there, they will go anywhere and they can deliver and come. Okay, so here what you have to do is, if the size is very large, you have to break that into smaller pieces so that it can be accommodated in the network. Okay, so this part is done here in the data link layer. Data link layer, what it does is it breaks this packet. So remember, at the top layer, your application layer, the packet size may be very very large. So you may have very large capacity packets may be there. The same such a lengthy packet cannot be given in this particular network, whichever it is, either your coaxial cable or any other optical cable or any other. Everybody has their own restriction, they can't take it. So here what this logical layer will do is, it will break it into smaller pieces, and this smaller pieces is called as frames, not the packet. Now if you ask me, then what is packet? Packet is sorry, this capital lock is there. Okay, so this frames are at this layer. Where are the packets? Packets are in network layer. So whenever we say, generally we say it is a packet, but it's not packet. Packet is in the network layer. Data link layer, it is a frame. So who is responsible for generating this frame is the LLC. Okay, who is responsible for controlling is media access. So these two layers are there. So whenever you want to make the communication, you have to have this logical link. LL is required and the CSMSCD is required for the MAC layer. Now coming back to our simulation, now you got the idea that what are the things which are required. So let's try to build a simulation over here, and I'm going to know what was the password. Okay, so this I have my Ubuntu in my virtual machine. Hope my password I forget my password sometime. Okay, so this is what we are supposed to do, and let's try to build the network. By the way, I will give the full credit to the BOS member, I think Board of Studies, who have provided this full exercise, and there is no effort from my side to develop the application. I will give the full credit to the Mangalore University BOS team for giving me this manual, and I am just copy pasting it from the manual. Sorry about that. So I am not developing anything. I have just copy pasted. The reason is there is nothing much to be done. Whatever they have done is correct. So I can't say that. So it's like if they have taken the variable n here, the only thing I can do is I can take the variable as x there. So is there a fun in changing the variable from a to x and saying that that is my code? It is not. It is their code. I am just using it. So please refer in your college also. This particular lab manual is provided for free by the Mangalore University BOS team. So if you have not collected, please collect them. This is for the teachers, not for student. My students, you come and collect it from me, and I'm going to give it because somebody else has given it to me. So let's start the simulation. We will start with the simulator. We need a simulator. So we create a variable ns, which is of type simulator. That's the first part. And we need to trace this one so that at the end we are going to get a thing like this. Okay, we are going to get something of this type. So we will create a file. This could be anything, my file, your file, their file, or anything. This is a file name. That is in your C program, fe is equal to f open. You said that f open file pointer, like that. This is a pointer to a file called as out.nam. This is the original file which will be created during the simulation. So you write whatever the actions are happening over here, you write it to this particular output file. It will be there in your folder, and then you say trace all the activities, that is nam trace all. So all the activity that is required for the network animator, and store it in this nf, which is the variable that was created. And this procedure you can write it at the beginning, at the end, or anything. So generally it is better you write it at the beginning itself, so that you will say that what will happen when the simulation ends. When your simulation ends, you write a function. This function could be anything like square root, find area, or anything. You can write any name here. It need not be always finish. So that's the name of the function, like how you have the square, the sine function, cos function, like that. One function called as a finish, and it takes two global variable. One is this ns, and the other one is nf. So because you have to get the instance of your simulator as well as the file, you flush all the traces which you have collected here. So as the simulator simulates it, it's going to generate the simulation script, or it's going to generate all the parameter values. Those values which are there in this nam trace, you say flush it. That means transfer everything to the file, close that file. So if you have written C program, f close. At the end you start f open to open the file, and you then at the end when you write the C program, everybody is familiar, then you write f close to close the file. You close that file, and then you call this network emulator NAM, that is this, and you give this output file. You don't give the file pointer to it, remember. There is no point of giving a file pointer to somebody else. So just imagine you write C program and you give FP to somebody else. What they will do, they can't get. You give the file to them and say open this file and see what is there. So that is what you are saying to the network emulator, that okay, open this file and I have all the tracing information, take it and show the animation, and finally you exit out of this program and tell the operating system that everything went smooth. Now coming to this part, if you look at here, there are 5 nodes are there starting from 0 to 4. So you start one node, a variable name. NS is your simulator. Remember at the beginning you created the simulator. This is required. Okay, NS is the simulator, and you create a node. Okay. Similarly, N2 is the other node. N3 is and so on. So for you create all the 5 nodes starting from N0, N1, N2, N3, N4. All the 4 nodes are created with the, how do you create it? Set is the your syntax. Set variable equal to the object that you are creating, instance of the object. In this case, instance of the object is the node which is created by the simulator. So you have all the 4 nodes over here. You have to connect them together. For that you need a LAN. I told you, you need a LAN for the connection. So you create a variable. Now remember, this LAN is not because you created this one. Set is a variable. Okay, so it's a variable name. So it could be X, it could be Y, it could be Z, it could be anything. So I'm going to just show that whole thing. So set variable name is equal to new LAN. You are going to create a LAN and you are going to give all these nodes which are created, N1, N0, N1, N2, N3, all of them has to be connected. All of them has to be written with the space separation. Very important thing over here. There is a space separation and you put them in double quotes. Okay, if you have 10 here, put all the 10s over here. And I've already told you there is a limit with which it can transmit the packet. So you know very well, highway you can take a very large truck. In Nukkad or in Gully or Oni you can send only small pickup. So what is the capacity? Capacity is 0.5 MB, and I've already told you it is going to take some time for the packet to travel from one side to the other. That means to say that there is going to be a delay, and that delay is 40 milliseconds. You can change these parameters and then see what is the effect. LL is your logical link. You have to maintain a queue because you know very well, when unwanted packets arrive, they are dropped. Okay, that's why you say drop tail. So for the logical link, and in the MAC layer you use CSMA CD, and you use this channel CSMA CD channel of the MAC layer. So that is what is being written there. And then now you decide who is going to communicate. Now rest part is same as the previous one. If you want one node to communicate with the other node, there must be a TCP agent over here and TCP sync on the other side. So you generate those TCP agent and connect to the node that is want to send the packet, and TCP sync and connect them to the destination where it is going to receive it. And definitely you have to have a logical link between the source and the destination. So let's look at that one. So here I will create a TCP agent, which is the source agent that I'm going to create. Again, set variable name is equal to new TCP agent. Okay, and there is only one flow in this particular communication. It's going to take only one flow. So you say class 1 and then attach it to the node 1. So what is the meaning of this? You attach it to the NS attach agent NS1. What is the meaning of that is you are going to attach this variable. Remember this is the TCP0 is the variable name. This variable is the one that you have created, TCP agent variable name, that you attach it to N1. So N1 is attached with the TCP agent. What is that? What does that mean to you? So this N1 here, this is N0, this is N1. N1 will act as the source now. So that is the meaning. N1 will be the source. It's going to send the packet. Now the next question is, who is going to receive them? If it is going to send it, who is going to receive it? The receiver is the agent TCP sync. So agent slash TCP sync is the receiver. You give any variable, and it is better you give a variable that makes sense. In this case they have taken it as sync 0. That's the agent. Attach this particular sync to the N3. So you attach this sync which you have created over here. Now again, some student, you said you are using dollar, sir. Why you are using dollar? Why not you use the variable name? Now I'm not sure. If you have studied this PHP, that story you would have got it. In PHP also, when we want to use it, we start using the dollar. See, this is using the variable. This is the declaration of the variable. During the declaration, we don't use the dollar. When we want to get the value out of it, we use the dollar. It's like, again, I don't want to confuse you. If you have seen this pointer, when you want to get the value of the pointer, you say star PTR. Star means you get the value. Okay. So that kind of thing, this is a dollar to indicate that the value which is there. So this is a declaration of the variable. Okay, let's look at what we have done. So we have connected the sync to N3. So what does these two things mean? We have connected to the source N, this one source. Okay, we have connected the sync to this 3. So N1, this node 1 wants to communicate with the node 3. What about all these 3? They will have to just look and see what is going on. So other nodes will not participate in this whole communication. Remember, it's not enough if you just attach a sync and source to this one. So in other words, it is not enough if you generate a TCP source here, and if you generate a sync here, it's not enough. Okay, you have to physically connect them, not physically, you have to logically connect them together to say that if this is the physical connection, along this I want to send it to the other. So these two has to be connected, and that is what is being done over here. So you then say that source and sync, this is the TCP source and the sync, these two variables has to be connected together. So that is what is being done. Now if you just connect them, nothing is going to happen. There must be somebody who is going to generate the packet for you, and the packet will be generated by the CBR. So constantly you generate the bits. So CBR is the constant bit generator. So you say application traffic CBR. This is the CBR traffic that you are going to generate. And again, some of you may say that see, to send the communication you need TCP and you need IP address and other things. Do not get confused. We are not talking about the network layer over here. We are talking about the data link layer. Again, I told you that your IP address will not come at this particular layer. So don't get confused there. Okay. If you get confused, just take it for granted that somebody else is going to take care of the IP address. Okay, and thank God that it is not there. Otherwise, you have to write the script for generating the IP address. Okay, so let's look at this one. CBR0. This is a variable, and it's going to generate a CBR packet. How do you write application traffic CBR? You're going to generate a CBR traffic of CBR. And then you have to set what is the size of the packet. If the size of the packet is very large, it has to be fragmented down. At what interval it is going to be generated? So every 0.01 second you are going to generate. That means quickly you are going to generate many packets one after the other, and you will going to attach this CBR to the source. So let's look at what we have done so far. We have created a source TCP source here. We have attached it there. We have created a sink here, we have attached it, we have connected them together, source and sink, logically we have connected them together, and then we say that there is a CVR source that is going to give the packets to this agent, and agent is going to take it and give it to the destination. So that is what is being done there. So that is the idea that we have it over here. The next part is all done, your connection, everything is done. Now you have to say at what time your show will start and at what time your show will end, and when you are going to exit. So that is the two things. So you say that at 0.05, that is 0.05 of a second, you will start you will tell the CBR over here that CBR 0, that's a variable. You say you start the generating the packet at 4.5 second, you stop the packets, okay, then wait for next 0.5 seconds, and at 5 you say to the, see it, look at it here, you are saying it to everything, you are saying it to the simulator, you are saying it to the NS, and you say that at 0.5 start the CBR packet. NS, that is the simulator, at 4.5 stop the simulator. NS at 5 seconds you call this finish. Now what is this finish? Finish is this function that you just created. So instead of finish, if you have typed exit there, or if you said my function, it is going to close anything, square root, sine, cube, whatever you have written, that function name should be written here. So that finish means you call that function there, sorry, this is not function, that is procedure, you call that procedure there, okay, and everything is done, but you have not told a very important thing to the simulator that you start it. So how do you say that? At the end, the last thing is you say run your program. So run your simulation, this is what you are going to say. Now when you run this particular script, you get a warning message. Now you may get the warning message or you may not get the warning message. In my case, something is not there, it's saying that something, a warning message is going to come. And you know very well, as a student you always ignore warning. So where is my script? First of all, I'm going to clear this because I'm running it. I'm going to close this one, and also I'm going to close NAM over here. I was running, that is why you are able to see it. Now I have created on my desktop, I created a folder called as lab, and inside this lab I have saved this file now, ex4 dot this, inside that I have saved it here, and you see this the NAM is also created. Who created this NAM? This output file I have just shown you here because I executed this script once, that is why you will notice this output.nam. So this is the file, that file was created. So right at the beginning you created this file. Now this particular file is this, it will not be there at the beginning. When you run the simulator, this file gets generated, okay. So I'm going to just close it, clear this one. So let me clear, I think I will zoom it out so that you can see what I'm typing. Okay, zooming will take some time. Okay, so you see there, I'm going to just type CD so that I'm in the home here. Where is the CD? Did it CD? It is a bit okay. Where is the CD? Okay, press enter, and I'm in the my home directory now. If you see this home directory, I'm in the home directory now. Now if you look at this one, I think we'll have to zoom out, and I'm in the home directory, okay, home of money, and in the home of money I have this desktop, my document, my downloads, and so on and so forth. If I run this ls command, I'm going to see that one. I'm going to just type that ls here, you will see that same thing, but without all the colors over here. So this is your desktop, this is my document, this is downloads, this is music, and so on. All of them are folder which will come in one different color. Don't expect your machine to show it in blue color, it may show it in green color, but it will generally highlight it with some color. Now I want to enter into the desktop over here. Suppose if I double click the desktop, I will see these two things. What you see here in your desktop, open it, and so these two things, that is lab and network manual, these two will be there. So how do I go into the my desktop over here? Is I type cd, change the directory to desktop. Okay, did it took that thing? Okay, cd, and I'm going to say desktop. Okay, cd desktop, I press enter, I'm inside desktop now. You see there, I'm inside desktop now. So that is where I am there now. Now if I type ls, I'm going to see two things. One is computer network lab manual, and the other is the folder. This is what you are going to see. One is this file in the desktop, other one is the lab. I don't have anything in my desktop. Now I will open this lab here. I open this lab. Now inside this lab, you are going to see two files. Actually you are going to see one more file, which is a hidden file. That is the temporary file that is created by this gedit. Okay, so I will enter this lab. I say cd, and let me click here and then say cd, and then I'm going to say lab. Okay, press enter. Now I'm inside the desktop and I'm inside the lab here, and now I'm going to say ls, just to say what is there. See, you see this ex4.tcl and out.nam, two files are there. This one you see there with the tilde there, that is the temporary file created by the editor. So when you open this gedit, it creates a temporary file for its purpose. If you close that, this file is automatically deleted. It's like it's housekeeping work is taken care by the gedit. Now I have to start this file now. So I'm going to say ns here, and I'm going to say ex4.tcl. I'm going to get a error here. I'm going to show that thing, error. So not error, the warning, no class variable LAN router dot debug. You will get that thing. If you get it, you are luckiest one. If you are not getting it, you are not luckiest one. What I can do about it? I am the luckiest one to get that error, but your simulation will work, don't worry, even if you get that. Okay, so I have the simulator, but when you open this simulator, you find that this is all garbled. Okay, you find you will say that, is this the LAN that I was supposed to create? The answer is yes, it is the LAN. Only thing that you have to do is double click and get it there, and manually, before you call your external examiner, just get them at the proper location. How do you get it? Just you can't drag it. First click here, this location. Remember, first click at this location. You click at this location, then you will be able to edit it. Okay, you do that one, then you will be able to edit it. Once you click on this, you will be able to drag these pieces and get them at proper location. Get one at one location, put them at the proper location maybe, and two was there, no? Yeah, I think you have to try this. Okay, this is going to check your nerves, no doubt. And finally, are you happy with this one, or should I take you up? Can I take you here? Okay, then maybe I can take him here. Now, if you're wondering why I'm doing it, I want to just maintain one gap here. Otherwise, you find that both are connected there. And also, I will keep these people outside. Okay, I know, because I've done the simulation. I know why I'm supposed to keep them away from each other, because they are going to. I think I will not waste your time by playing like this. You will say that, what is that, sir? why can't you do this at home and enjoy while you are recording? Okay, isn't that, see, even though they appear to be connected, they are not actually connected, they are far away, sometimes it comes, sometimes it just goes here and there. But why I have kept these two separate is they are going to communicate. Okay, so communication path is there, all of them are going to drop their packet and you will see very garbage thing over there. So let me start the simulation without talking much. Let me start the simulation. Remember, up to 4.5 there is no action. So I will zoom out and I'm going to show you at 4.5 there is no action. So I'm going to stop it, and what I'm going to do is let me zoom out and do that thing. I will drag this one so that it will come around 4.5. Okay, so 4. Okay, 6 4.4, and I'm going to reduce the speed. Okay, I've dragged it, you can drag it. Okay, and then I've adjusted in your video. If you are not able to see it, what I am in my desktop I am able to see it. I am adjusting this timing there so that it will come to 4.5. Why this 4.5 is somebody said anything to me about that is, you know very well, at 4.5 your action will start. This is what you have written. Let's look at what you have written here. At this sorry, not this 4.5, sorry, 0.5, sorry, is it wrong, I suppose. At 0.5 you will start it. So there is nothing up to 4.5, nothing is going to come. So forget, why to waste time in that. Okay, so I'm going to go with this 4.4 and it is slightly 4.8. Okay, and I'm going to run this one in slow motion. Okay, and see, just see, the first you send the control packet. So the communication is between node 1 and node 3. So node 1 will first send the, saying that, see, I want to send the packet, the other side must be able to receive it. First you say that you simply don't send the packet and say okay, you take it. Other side will say I was not ready, don't send it unnecessarily, don't send it. So you send this control packet, it's not the data. But this packet, when it reaches here, it's going to replicate it. See, you see that in action. When it goes here, you see there. Okay, you see this packet, it reached here, it's going to go to this node, it's going to do to this node, it's going to go to this node. All of them have nothing to do with this communication, still they are going to get it. Okay, and what are they going to do? Let's see, all of them are getting this request, and all of them, once I get okay, you receive it to node 3. What is written in this is node 3, I'm going to send the data to you. The node 2 will say I am not node 3, why you are sending it to me? So it's going to discard it. You see there, see the action, see it's, you see that it's going to discard it. It's going to tear it out and say you send or you die, I am not interested in your communication. So it's going to simply discard this packet. You see there, it's going to discard that packet. Have you noticed this particular thing? It's going to discard that. Okay, and when you see that, and you see it is this, don't get fascinated by this one now. Now see, the node 3 is replying back, okay, you send, I will take it now, I am free now, you can send this acknowledgement, it is sending back. You see, acknowledgement is also getting replicated. You see that by the time acknowledgement reaches here, you see that acknowledgement, can you see that this is the acknowledgement, it also gets replicated to all of them, and all of them will also say you send they node this packet, this communication, when it reaches to node 4, node 3 and node 4 and node 0 and node 2, they will say I have never told you that I'm going to send this anything to you, why are you sending it to me? So what they will do is, when they receive this acknowledgement, only node 1 is happy that I'm getting acknowledgement, others will simply tear it down and send it back. Okay, so this is what happens when you have the land there. What is going to happen there is everybody will unnecessarily get the packets, and what they have to do is they must prepare themselves to tear down it. And you see, okay, so this, you see, acknowledgement is received. Now the node 3 said, okay, send the packet, this is the data packet. Now you see what happens when the data packet comes here. You see, I'm running it very slow, and that data packet is you see there. Now you see the real problem. That is also a lot of noise across this network, because it is also getting replicated and everybody is getting the data. They were not part of this communication at all. They were simply on their own. They got the acknowledgement from both the side. They are also sending the data to them, and they are the other people who are here, other nodes over here, they will get irritated by now. See, they're simply getting the packet, and what they can do, node 3 may be very happy that I have received some data. Others are not happy because they have nothing to do with them, and what they will do is they will simply drop it. That is what is you have said, drop the packet. Once you don't, if it is not yours, you drop it, and this whole story will continue, and it keeps on going again and again. If I fast forward it now, you will see that it is just dropping, and your simulation will stop. I will not waste your time. I will drag this one. This story will continue, and I'm going to drag this over here, and I'm going just to show you that this story will continue up to 4.5. and you see how many packets are getting dropped like anything. And at 4.5, node 1 is not sending anything, others have dropped everything, and you will call the finish. That is all in this exercise. Thank you for your interest. We will meet again in the next exercise.